Thank you very much. It's really, really exciting to be here. So, big happy. So I'm going to talk about happiness. I'm going to talk about big things. I'm going to talk about heaps and heaps of data. And I'm going to talk about cities. And I'm going to talk about how we can use all of these things together to try and get some insight into the character of different cities. So that's my ultimate goal. But I'm going to start somewhere completely left of center of that and talk to you about animals. And so in particular, I'm going to talk about hedgehogs and foxes. This is an idea, or this is a metaphor, or it's a meme, which comes to us from Greek poetry in the 7th century BC, and it enters the modern consciousness through this philosopher Isaiah Berlin and his essay on Leo Tolstoy, through psychologists like Philip Tetlock, talking about political experts. And most recently, it comes to me through the political blogger and election forecaster extraordinaire Nate Silver in his book. So the quote here, the metaphor is that the fox knows many things, but the hedgehog knows one big thing. So the idea there is that the hedgehog is sort of an ideologue. The hedgehog is somebody who has a theory of how the world is going to work, and any data that they observe, they're going to try and put into that framework. Whereas the fox is more of a scavenger. The fox is going to go out and look at many different pieces of information, many different data sets, and try and form a picture of the world based on the panoply of all the different pieces of data that you see. So as an example, a hedgehog might be somebody who's a string theorist or a theoretical physicist who believes in one master equation for the entire universe. A Shakespeare is a fox, because events in Shakespearean plays occur because of many, many small little interactions between many, many small bits of information that get carried through the play, sort of chaotically. In his book, Nate Silver writes that Malcolm Gladwell, the author of the tipping point hypothesis, is a hedgehog. And Nate Silver would say that because Nate Silver is most certainly a fox. So if you look at their 538 website, it's all about combining different bits of data together to form an idea of how the election is going to run out. So we're going to talk about being foxes. We're going to talk about how we can use lots of little sets of data to form a picture, in this case, of cities and of populations in general. So here's one data set that we're going to look at. So this is a collection of geotagged tweets collected through the calendar year 2011 in the United States. So we've collected 80 million, more than 80 million actually, of these guys. And these are, and each dot here represents one single tweet. So this is each dot is a very, very small piece of information. So as somebody who uses Twitter, I can tell you that tweets are small pieces of information in every sense of the word. But they are incredibly rich. They're an incredibly diverse set of all the words and all the thoughts that people are talking about at any time. So being foxes, what we would like to do with this is we'd like to combine it with some other set of data and see what it can tell us about something. So in the United States at the moment, health and food and obesity is a big issue. So let's try and combine the words coming from these geotagged tweets with obesity data and see what it tells us about a place. So let's pick out one word that people talk about in geotagged tweets, McDonald's, and let's compare that with the obesity rate in the city in which they live. So each dot here represents one single city, and along the horizontal axis I'm plotting the percentage of obese people in that city. And on the y-axis, on the vertical axis, I'm plotting the rate at which the fraction of the time of the number of tweets that contain the word McDonald's. And so perhaps unsurprisingly, in this case, as one goes up, the other goes up as well. Maybe not surprising. But we're being foxes, so we don't just want to look at one word, we want to look at lots of words. So, so I'm somebody who likes to go out for brunch in Burlington and gorge myself on pancakes and stuff. So you might think that if I chose the word brunch, and I like to tweet about it, of course, that it might follow the same trend here. Turns out that it's exactly the opposite. The more that you talk about brunch, the less likely your city is to be obese. So what's going on here? This is really strange. And remember, this is just 2 words now out of all of the words that people speak, or that people tweet about. We can look at all of the words, and we want to look at all of the words because we're foxes. So we can correlate each word that people use of the most common words with obesity and come up with a list on the right of sort of fat words, obese words, and on the left, skinny words. So brunch is at the top of the skinny list, McDonald's is at the top of the fat list, and there are some words that you might expect on the obese list. So we've got spaghetti and IHOP are in there. A word that surprises me is hungry. And then the skinny list, the anti-correlating words with obesity are much more interesting. So we've got coffee and espresso in there and barista. Surprisingly to me, we've got booze, wines, cocktails, mimosa. Vegan and tofu here, they might make sense to you, but it's an interesting picture that you get just by looking at these words. So why is this useful? Obesity surveys are something that take a very, very long time to do, to get data and to get results for, and they're often out of date by the time that you've actually got them. So this is a real-time look into what obesity, or what things people are talking about and how they relate to obesity in different cities. And more importantly, if you look down this list, there's more of a story. There's a story being told here about these two different types of cities that's not just about food, right? Like if you look at some of the types of words on the left there, then this is not just a story. There's something deeper here going on. Okay, so we're being foxes. We want to look at different sets of data. Here's a different data set. So here I'm plotting something in each state in the US. It looks sort of like an electoral map, I suppose, that you've probably been seeing a lot of, except it's an alternate universe where New England is a red state, and down in the south are blue states. But it could be anything. It could be median household income. It could be number of supermarkets. It could be the average lifespan. It could be anything. Turns out that it's nothing like that nothing standard that you might think, unless you read the title of the talk, which is Big Happy. This is actually plotting happiness, or what we call average word happiness, in each of these states. So the happiest state ends up being Hawaii, because people talk about beach and holidays and sun and happy things there. Louisiana here has ended up being the saddest state, because people swear there a lot. So we can zoom in further. We can zoom into the city level. We can look at Manhattan. So each dot here is a tweet, a geotag tweet, and we're colouring regions by how happy they are. So Manhattan is happy. It turns out that the happiest intersection in Manhattan is where 77th and 7th would be, which is just inside Central Park near the Hayden Planetarium. And happiness tends to decrease as you go further downtown. Brooklyn is happy. New Jersey is less happy because it's blue. In the lower right, you can even see JFK Airport there, and there are happy terminals and sad terminals. So this is incredibly rich, and we can see an awful lot here. So the big question is, how do we do this? So how do we claim to know anything about happiness in different locations? So this is part of a larger effort that's going on here in the Computational Story Lab at UVM to measure happiness in real time. So we use something called the hodonometer, which we call the hodonometer. And the way that we built this was by being foxes, was by collecting lots and lots of little pieces of data. So what we did is we made a list of the 10,000 most commonly used words, and then asked hundreds and hundreds and thousands of people on the internet to rate each of these words on a scale of 1 to 9 on how happy they thought each word was. And then we collected up all that data, we averaged it together, and we did statistics on it. So we did a Fox-like thing. We collected it all together, and we came up with a rating for each of the most common words. So words like terrorist get low scores because they're sad, down near 1. Neutral words like the come in the middle, around about 5, almost exactly on 5 actually. And a word like Christmas or laughter is a happy word, so it comes with a score closer to 9. So it's an example of how this works. Here's the title of my talk, Big Happy. The words big and happy are both scored in the database. So they've got scores of 6.22 and 8.3. We add those two numbers up together and we divide by 2. So we take the average of the two scores for the two words and we come up with a score of 7.26. So this is a relatively happy score for this text. Now, of course, this is a completely nonsense example. This is a meaningless number that I've just shown you. Just as I wouldn't grab 2 molecules of air in this room and measure their vibrations and expect that to tell me what the temperature of the room was. So we need a lot of words and a lot of scores for words, the fox-like collecting a lot of data and putting it all together to come up with a reasonable estimate of what happiness is in a statistical sense. So cities present a good example for doing that. So we could collect all the words that are tweeted about in a city and combine them all together statistically, calculate the temperature of all of those, and come up with a happiness score for an entire city. So we can do that, and we can come up with we can come up with a list of the happiest and the saddest cities. So the Napa Valley in California ends up being the happiest city, and Vermont, Texas which is an industrial town, ends up being the saddest city. Flint, Michigan is there as well, and some cities in the south. And there are a lot of beachside cities in the happiest cities list. So we can zoom in further. So why is the Napa Valley the happiest city in the US? So this is something we call a word shift diagram. So all the words that are on the right of the diagram are increasing the happiness of that city relative to the rest of the United States. So you see some swear words up there that I've redacted at the top. So those swear words are being used less, and that increases the happiness of the city. And you also see words down the bottom like wine, food, dinner, and lunch. So some things that you might expect to see coming out of the Napa Valley. And this is what makes it the happiest city. So let's come back to the Fox picture. We want to not just look at one metric. We don't just want to look at happiness. We want to combine that with other data sets. So I'm recently married, so it behooves me to know whether being married increases my happiness or not. And so this is another scatter plot where each dot represents a city, and I'm plotting the percentage of population married in the city versus the happiness of that city. And fortunately enough for me, the correlation there goes up. So maybe I've increased my happiness by being married. But again, this is just one set of data that's collected from the census. So the census collects literally hundreds and hundreds of pieces of information every year about the demographics of that city. So we can take the correlation here, this number 0.370 in the bottom right, and make this graph be 1 point in another graph. So the percentage married appears up on the top right there. So what we've done here is you might expect that the percentage of people married in a city co-varies with other factors in that city, like having a child or having a house or having 2 cars, and it does. So we've grouped demographic clusters together first, without any reference to happiness, by just seeing which things are similar, so which things co-vary, and then we've calculated happiness of all of these demographic clusters. So the story here is, it's not quite that money buys you happiness, because correlation doesn't imply causation, but it does seem to suggest that money is statistically significantly spim and correlates with happiness, which is not as catchy. We need to work on the branding, but that's the idea. So what's this useful for? If I was the mayor of the city, I would like to know. I would like to have a gauge on how my city is feeling, and at a deeper level, I'd like to know how that relates to underlying factors in the city. So this is a piece of eye candy. This is my last slide. This is where we've grouped cities together just by how they use language similarly. So each coloured square here represents red colours represent 2 cities that use words in a similar fashion. So San Diego and San Francisco are up there in the top left. Yes, they use words similarly, and Memphis and New Orleans use words similarly in the bottom right. So if I were the mayor of the city, I would like to have a gauge. It would be interesting to me to know something about what the happiness in my city looks like, and at a deeper level, I'd like to know how that relates to other factors in my city and what cities I'm most like. So the main thing in the toolbox here is being able to combine disparate sets of data to be able to come up with a coherent picture of the character of a city. So the moral of my little fable here is to try not to be a hedgehog, but to think like a fox instead. Thank you.